Hey guys, this is a tricky one. We want the limit as x approaches 0 of this, which honestly reminds me of a previous question in this midterm. This one where we had the limit and it was a difference and we had a square root. You can just multiply by the conjugate in that case because it ends up canceling out the square root when you use difference of squares. But here we have the cube root. So the trick is to use something called difference of cubes, which says if you have something minus 1, then if you multiply it by that something squared plus that something plus 1, then you end up with that first thing cubed minus 1. Now that works out when you multiply your polynomials out, but here's how it actually matters for you. We want the cube root to eventually cancel out. We want the cube root under here. So we're going to make that whole thing x. What do we have to multiply it by in order to get that? Well, we have to multiply it by that squared, which in this case gives you the exponent of 2/3, plus that thing itself, that's the cube root of 1 plus 3x, and plus 1. Not only that, you have to put it in the top and the bottom. 3 cube root of 1 plus 3x squared plus the cube root of 1 plus 3x plus 1. When you multiply this fraction by that fraction, you end up with, and according to difference of cubes, this is true, 1 plus 3x. The cube root of that cubed is actually what you end up with, but the cube root and the cube cancel each other out. Minus 1, and in the bottom you're left with this atrocity, 1 plus 3x to the 2/3 plus 1 plus 3x to the 1/3 plus 1. What a mess. But luckily for us, 1 plus 3x minus 1 helps cancel itself out. You're left with 3x over x. And then this same monstrosity, it's going to take me an hour to write out. Notice these x's cancel each other out, and all of a sudden we have something that we're actually allowed to plug 0 into. Let's take a look. 3 divided by 1 plus 0 to the power of 2/3 plus 1 plus 0 to the power of 1/3 plus 1. I get 3 over 3, which turns out to be 1. The limit of this entire function as x approaches 0 turns out to be just 1. But again, the trick was identifying that you need to get rid of that cube root, and the way to do that, the best way to do that I've found, is to use a difference of cubes formula. If you didn't know what you had to multiply by to get there, you could have done long division of polynomials. You know you wanted it to eventually end up as x cubed minus 1. And you knew that you had to take x minus 1 out of that. When you do long division of polynomials here, I think you'll find remainder 0. I think you'll find that long division would have given you that in the first place. Anyways, hey, best of luck to you.